In this lesson, we are going to take an introduction to probability. We're going to begin with a few definitions with words that you are going to use quite frequently throughout our study of probability. First is an experiment. An experiment is an activity with varying results. The possible results of an experiment are called outcomes. A collection of one or more outcomes is an event, and the outcomes of a specific event are called favorable outcomes. So that kind of all sounds like a bunch of mess, so we're going to try to make it make sense very quickly for you. Here you have 6 marbles. Let's say these 6 marbles are in a bag. If you reached into that bag to pull out one marble, the possible outcomes that you may end up with are a blue marble, a green marble, purple, green, or red if you pulled out one. So the event, let's say I want you to choose 2 marbles. And the event that we want, because an event is a collection of one or more outcomes, the event that we're looking for is pulling 2 green marbles. Choosing a green marble. So if we want you to choose a green marble, how many favorable outcomes are there? Well, there are 2 green marbles. So the favorable outcomes for the event choosing a green marble, there are 2 of those. If I asked you how many favorable outcomes are there for choosing a blue marble, you would say 2. How many favorable outcomes are there for choosing a purple marble? Well, there would be 1. And how many favorable outcomes are there for choosing a red marble? There would be 1. There are multiple possible outcomes, but the favorable outcome is getting the specific outcome that you want for a particular event. And just another definition to kind of keep in your notes and keep in the back of your mind is that a sample space is the set of all possible outcomes. So first, the set of examples that we're going to start to work with is identifying outcomes. So a lot of times working with probability, we're going to be pulling marbles out of bags, we're going to be rolling number cubes, we're going to be spinning spinners, flipping coins, lots of things like that have different kinds of outcomes, different numbers of outcomes. So we're going to start with rolling a number cube. Now a number cube has 6 sides, numbered 1 through 6. So if I was rolling this number cube and I was asked what are the possible outcomes, well, I just said how many outcomes are there? There are 6. So what are the possible outcomes? We can be specific. We could say, well, 1, 2, 3, 4, 5, and 6. So there are 6 total outcomes possible. But these are the possible outcomes for rolling the number cube. In example B, what are the favorable outcomes of rolling an even number? So the even numbers on the number cube are what? 2, 4, and 6. Those are the favorable outcomes. Now, if it asked you how many favorable outcomes are there for rolling an even number, you would answer 3. But it asked you what are the favorable outcomes of rolling an even number, and that's 2, 4, and 6. Example C, what are the favorable outcomes of rolling a number greater than 5? Now, it doesn't say 5 or greater, it says greater than 5. And we know that on a number cube, we only have numbers from 1 through 6. So 6 is the only number greater than 5. And so the only favorable outcome here of rolling a number greater than 5 is 6. And that leaves 1 favorable outcome for that scenario. Now here is an example with a spinner. So let's say you spin that spinner. How many possible outcomes are there? Total outcomes. We're not talking about favorable outcomes because we're not talking about specifics, but how many possible outcomes are there? Well, there are 1, 2, 3, 4, 5, 6 different sections. And so there are 6 sections, so there are 6 possible outcomes. Okay. And then the next question asks you, how many ways can red occur? Well, if you look at all 6 possible outcomes, there are 3 red spaces, so red can occur in 3 ways, because red, the spinner could land here, the spinner could land here, or the spinner could land here. So 3 ways would be the appropriate way to answer that question. In how many ways can spinning not purple occur? Not purple. Well, we have 1 purple sector, but how many not purple do we have? 1, 2, 3, 4, 5. So the answer to that would be 5 ways. What are the favorable outcomes of spinning not purple? So this is a different question. We know there are 5 ways to spin not purple. Now the question, what are the favorable outcomes, is asking you what are those 5 ways. Be specific and make sure you name all of the 5 ways. So I see red is not purple. Blue is not purple. Red, again, you already named red, but you said there were 5 ways. So you need to list them all, even if a color repeats. So red, green, and then red one more time. So because there are 5 ways, not purple can be red, blue, red, green, or red. And we say red 3 times because there are 3 separate red pieces of that spinner in this case. Okay. So then we get into the actual terminology of the word probability. The probability, and this is a very important definition, of an event is a number that measures the likelihood that the event will occur. So the probability that a particular event will occur. What is the probability of having nachos for lunch? There are lots of different options for lunch. Nachos are one of them, so that would register 1 out of a certain number of options. It's going to be a fraction amount. It's either going to be likely or unlikely, and we'll talk about those things. Probabilities are measured between 0 and 1. This includes 0 and 1. Very important that you understand that the probabilities are including 0 and 1. Probabilities can be written as fractions, decimals, or percents. So all of your knowledge that you have with those kinds of numbers up to this point are going to prove very valuable for understanding probability. Now I said that probability measures likelihood. So let's talk about the likelihood of something and how that measures with probability. Now I talked about the probability of having nachos for lunch in the cafeteria. Well, there are 5 different likelihoods that we would use to verbalize, to articulate how likely it is. If there was no chance at all, meaning it's never been an option, it never will be, that would be impossible. Because that would be 0 out of all of the possibilities, and that would measure as 0 as a fraction, so that would be 0%. Unlikely is another way that we can articulate how possible, how likely something is to happen. We can have something that is equally likely to happen or not happen, meaning there's a 50-50 chance, which is interesting that we can say it that way because we also measure that using 50%, and it's also 1/2. If something is likely to happen, then it is a greater than 50% chance. We're going to measure likely around 75%, which as a fraction is 3/4. And then if something is certain to happen, it's a 100% chance that it will occur. Makes sense? That is the number 1. Recall back to when we worked with fractions, decimals, and percents, and I had the circles. 1 as a fraction, 1 as a decimal is 100% as a percent. So this will help you very much. This spectrum is incredibly powerful, I think, to helping you understand the likelihoods as probabilities. So let's start off with a couple of examples. You have 10 coins in your pocket. 5 of them are are Susan B. Anthony dollars, 2 are golden dollars, and 3 are presidential dollars. In how many ways can choosing not a presidential dollar occur? So we have 5 Susan B. Anthony dollars, and I've already drawn out 10 coins, and I've separated them based on this. So these 5 are Susan B. Anthony dollars. We have 2 that are golden dollars, and we have 3 that are presidential dollars. Okay? In how many ways can choosing not a presidential dollar occur? In how many ways? If I reached in my pocket to pull out 1, how many ways can I pull one that's not a presidential dollar? Well, I have 5 Susan B. Anthony, so that's 5 ways. I have 2 golden dollars that are not presidential dollars. That's 2 more ways. So I've got 1, 2, 3, 4, 5, 6, 7 ways that I can pull out not a presidential dollar. So that's simple. That's it. Okay? A bargain bin contains classical CDs and rock CDs. There are 60 CDs in the bin. You are equally likely to randomly choose a classical CD or a rock CD from the bin. It's a very powerful statement, equally likely. If you look back at your spectrum, equally likely is what percent? 50%. Okay, so 50% of the 60 CDs. How many CDs are classical CDs? Well, we have classical CDs, we have rock CDs. You're equally likely to choose rock as classical. So if you have 60 total, and we know that equally likely means 50%, we can think of this as 50% of 60. Now we've worked a ton of ways with how do you find 50% of something. You can divide it by 2, you can multiply it by 5/10. So I know, and I can even say mentally, that 60 divided by 2 will find me 50% of 60, and that's going to give me 30 CDs. Read back over the question, make sure it makes sense, and double check your answer. If you're equally likely to randomly choose a classical CD or a rock CD from the bin, and there are 60 to begin with, 30 CDs for classical makes perfect sense. Lastly, we have some true or false questions, and these aren't just any true or false questions. They're my favorite kind and your favorite kind. If false, make the statement true. So we have 2 spinners here. Please forgive how ugly they are. I have spinner A and spinner B. This is an orange sector, by the way. So it's orange here, red, green, and blue. This one is green, blue, and red. So true or false? A. There are 3 possible outcomes of spinning spinner A. Well, how many pieces are there? 1, 2, 3, 4, 5. I'm thinking that there are 5 possible outcomes, but there are 3 colors. So maybe it's true, maybe it's false. All of the possible outcomes. Well, how many ways can I get blue? I can get blue in 2 ways. I can get red in 2 ways. So I actually think this is false. Because there are not 3 outcomes. There are actually 5 possible outcomes. And that would be how we would make this statement true. We would replace there are 3 with there are 5 possible outcomes of spinning spinner A. Example B. Spinning red can occur 4 ways on spinner B. If we look at spinner B, how many places do we see red? 1, 2, 3, 4. So spinning red can occur 4 ways. I say that is in fact true. What about spinning blue and green? Spinning blue and green are equally likely on spinner A. Well, blue can occur 2 ways and green can occur 1 way. Do I have an equal chance of spinning blue and green? I think spinning blue is more likely than spinning green because there's only 1 possible outcome for green. So this is false. But are there 2 sectors that are equally likely, or 2 colors that are equally likely? I've got 2 blue pieces of the spinner and 2 red pieces of the spinner. So I believe that spinning blue and red are equally likely on spinner A. So I would get rid of green and replace it with red. Okay? Example D. It is impossible impossible to spin purple on spinner B. So therefore, it is certain to not spin purple on spinner B. Well, do you see any purple? Got orange, blue, red, green. No purple. So is it impossible to spin purple on spinner B? Yes, that's true. But the second part, so it is certain to not spin purple on spinner B. True. So our answer is true. Okay? And then I put this statement at the bottom that I want you to think about, and we're going to talk about here for a second. There are more red sections on spinner B than on spinner A. So there are 2 on spinner A and 4 on spinner B. Is it more likely then to spin red on spinner B? Well, let's talk about this. On spinner A, the red sections are larger than the red sections on spinner B. Because there are fewer sections on spinner B, they're smaller. So size of the sections on the spinner matters, and the total number of sections on that spinner matters. Think about this for a second. 2 out of the 5 sections on spinner A are red. So I'm just going to write that, 2 out of 5 on spinner A. And on spinner B, 1, 2, 3, 4 out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 out of the 10 are red. So we can start thinking about probability in this way. 2 out of 5 and 4 out of 10. Is it more likely to get red on B? Well, isn't 4/10 equivalent to 2/5? So when you're looking for likelihood, you have to keep in mind the total amount of stuff. So 4/10 is equally as likely as 2/5 because those are equivalent ratios. So keep that in mind. It is not more likely to get red on spinner B than it is on spinner A. It's actually equally as likely, and we'll talk more about that later.